Before we set up our experiment, let's do a quick recap on the difference between independent and dependent variable. The independent variable is the one that you are altering, the one that you are deliberately changing to see whether or not it has an effect on the dependent variable. So in an experiment, the goal is to alter the independent variable and see whether or not it changes the dependent variable. Think of the independent variable as the cause and the dependent variable as the effect. Will changing the independent variable affects the dependent variable? That's what the experiment is about. Let's say we want to determine if driving with the windows down will save fuel. So in this experiment, the independent variable will be to drive with the windows down or to drive with the windows closed. You choose to open the window or not. You are in control. Therefore, that is the independent variable. So that's the cause, right? What's the effect? What are we trying to measure? The dependent variable, the one that we're trying to observe or measure in this case, would be the fuel consumption. Okay, so that's not something you can control. That's the outcome that you are trying to observe. Let's try another experiment. Let's say we want to know whether or not the cows will make more milk if you feed them a high protein diet. So you set up your experiment. You have two groups of cows. One group of cows would have standard diet. The other group of cows are going to have high protein diet. You choose which group gets what diet, right? So that's the independent variable, right? The type of diet. The dependent variable is the one that you are trying to observe, that you're trying to measure. In this case, after feeding the cows with regular or high protein diet, you want to measure how much milk they produce. So the milk yield is the dependent variable. Okay. So one last time, the one that you are deliberately changing, that you are in control of, the cause of the experiment, that's the independent variable. The one that you're observing, the one that you're measuring, the one that you don't have control over, the effect, right, that you are trying to see from your experiment, that's the dependent variable. Let's think more about our cow experiment. Let's say it turns out the cows that were fed with a high protein diet produce more milk. But how can we be sure this was caused by the higher protein diet and not anything else? How do we know it was not because some cows were younger? Maybe some cows were healthier. Maybe it was because those cows stay in a nicer barn and therefore they're less stressed out and so they're able to make more milk. How do we know that? Well, that's because in any experiment, we have to standardize the conditions between the experimental groups. Other than the independent variable, which is the diet in this case, other than that, everything else must be standardized. Everything else must be the same. The cows in the two groups must be same age, they must be same health condition, they must be fed the same time of the day, and they would have the same living environment. Right? Everything should be the same except for the protein content in their diet. So what's the purpose of standardizing everything else? If everything else stays the same and the only thing that's different is how much protein they're getting in the diet, then any observable difference in the dependent variable in the milk yield has to be caused by the difference in diet and not anything else. Because everything else is the same. The only thing that's different between the two groups is how much proteins you're feeding them. So if in the end, one group makes more milk than the other, you know it was caused by the protein difference and not anything else. So that's why we have to standardize variable. Okay, so to put it nicely, right, in a summary sentence, I guess, The purpose of standardizing variables is to ensure that we can say with confidence any observable difference that is noticed in a dependent variable is actually caused by the independent variable and not anything else. When we record our observations, there are two kinds of data we can collect. We can be doing qualitative observations using our senses. So in the case of our beetroot experiment, we will be observing how much color is coming out of the beet. That's a visual examination, and that's qualitative. You can't really plot that on a graph. But the other kind of observation we can make is quantitative observation that involves measurements using instruments to measure various things, and those are numeric values, and we can plot those, okay, on a graph. Plotting numbers on a graph makes it easier to interpret the results. It helps us organize it better, identify trends, but we need to know what variable goes on which axis. The vertical axis is called the y-axis, and that is where we will put the dependent variable, whereas the horizontal axis, that's where you're going to put the independent variable. Later on in another clip, I will be telling you how qualitative and quantitative observations are going to be made with respect to the beetroot experiment. But right now, I just want you to become familiar with what variable goes on which axis. Vertical axis, dependent variable. Horizontal axis, independent variable.